Good afternoon and welcome to today's webinar covering details of 3GPP Release 16 and an introduction to Release 17. My name is Joe Bush and I'm the Managing Editor at Electronics Specifier, and I will be your moderator for today's session. Release 16, also referred to as 5G Phase 2, is focused on improving the gaps in Release 15 and has a key focus on industry verticals. Release 16 specification will be due for completion in June of this year, and this webinar will present details of this release whilst also providing an introduction to 3GPP Release 17. So key takeaways from today's session will be an understanding of the details of 3GPP Release 16, new improvements in standards focused on industry verticals, details on 5G V2x, details on Industrial IoT and ultra-reliable low-latency communication enhancements, and an introduction to key contents of Release 3GPP 17. Your presenter for today's webinar will be Vikas Chauhan from Anritsu. Vikas has over 18 years' experience in the wireless telecoms and test and measurement industries, and having led industry testing and strategies in 2G, 3G and 4G, he is now driving 5G activities across the industry for Anritsu. Following on from today's presentation, we will also have time for a brief Q&A session, so please feel free to submit any questions you may have as we go through today's webinar. So without further ado, please enjoy today's session, and I would like to hand over to today's presenter, Vikas.
Thanks a lot, Joe, for the nice introduction. Hello to everybody and welcome to the webinar. So today's webinar, as Joe mentioned, is about details of 3GPP Release 16 and introduction to 3GPP Release 17. So here is the content slide where in the beginning we talked a bit on the standardization update on Release 16. Then we go through details of the key features that have been introduced in 3GPP Release 16. And then in the final part, we go through the introduction to 3GPP Release 17. What we see here is the Release 16 and Release 17 standardization timeline. On Release 16 part, when we look at the Q4 of 2019, when the last RAN plenary meeting was being organized in December. This was RAN 86. So at this time frame, all the Release 16 RAN 1 was frozen and agreed. So when we look at Release 16 from past, already the stage 1, the requirements, and the stage was finished in December 2018. Then stage 2 was frozen in June 2019, and now we are getting into the RAN 1 freeze, which is done in December 2019 in RAN 86, and now we are looking into future development of standardization, finally getting on to Release 16 ASN1 freeze towards the middle of 2020. So there are a lot of features that are already matured, and there are some which are being fine-tuned. So moving on to the key features in Release 16 here. So in Release 16, there are two parts in which we can divide the focus area of Release 16. The part 1, where the Release 16 addresses the use cases of 5G beyond the mobile phone or just mobile broadband. So getting into industry verticals. And the second part is where there are old features that are refined and the new features introduced, improved. So this is on the generic system improvements and enhancements. So when we look at the first part, the industry verticals, the focus is on 3 distinct pillars. The first pillar is related to 5G V2x. And this is more focused on the automotive industry vertical, where the target is to address advanced use cases beyond LTE V2X, primarily focused on low latency. We will see this in more detail in coming slides. Then the second pillar is the Industrial IoT and URLLC enhancements. This is covering the Industry 4.0 requirements. So basically adding the 5G NR into smart factories, and the features have been introduced to help this integration of 5G. Then the third pillar is on expanding the deployment of 5G, where 5G NR operation is not just in the license bands, but it goes beyond license band, and similar to LTE, like we have got LTE unlicensed with licenses assisted access. Similar to that, NR can also be deployed more freely, more widely. And in addition to that, there is also a standalone unlicensed operation that is being also defined. Then moving on to generic system improvements and enhancements. So improvements to location and positioning capabilities. Then we have got MIMO enhancements, especially in the FR2 area, where the technology is still getting matured. Then on the power consumption side, where we address the power consumption of both the network and the device. This is one of the critical areas also. Mobility enhancements to improve the reliability of the connection. Enhancements in dual connectivity and carrier aggregation to have more effective deployment of 5G. Then the final one here is integrated access and backhaul. This is more related to utilizing the 5G not just to communicate with the devices, but also utilizing 5G in more integrated way to connect to the back end of the network. There is more detail in the coming slides, so we will move to the next slide. But in summary, release 16 is a big release, and it has got lots of new features and lots of enhancements to the old features. The first one is 5G V2X. So just going back into history of V2X. So when 3GPP introduced V2X for vehicle communication, it was introduced in release 14, and it was called as 3GPP V2X Phase 1, which was focused on basic road safety features. Then in release 15, the LTE-based V2X was evolved, and this was called as 3GPP V2X Phase 2. This was focused on advanced road safety features, having some more features in side link, which are related to increasing the capacity, reducing the latency. Then basic idea was that this was around LTE, so it was using the release 14 UE along with release 15 V2X enhancements in the same resource pool, using the same resource in the protocol stack. Then also some advanced use cases were supported, and this was done as a overall network enhancement to support advanced V2X services such as vehicle platooning, extended sensors, advanced driving, and remote driving. Then after 3GPP V2X Phase 2, in release 16, this evolved into 3GPP V2x Phase 3, where it is evolved into V2x based on NR. So NR-based side link has been introduced, and also all the existing V2x services that were developed in release 15 to support the advanced V2x use cases are also carried forward into 3GPP V2x Phase 3. Then if we look at key features in release 16 specifically, so NR side link, as I said, is a key feature here, which is adding the capability of new radio for side link communication, and it supports side link unicast, groupcast, broadcast, along with, as per the previous LTE-based V2X. In NR also there is in-network coverage and out-of-network coverage and partial network coverage, so different scenarios are there. But eventually it's possible for car-to-car communication based on NR V2X, and both NR V2X side link and LTE V2X side links are supported, and both can be supported when it's in coverage. It can be supported by using the NR G node B or EU-tran E node B. As we see in the picture there, we can see that both 5G core with NR G node B and 5G core with EU-tran E node B is supported for both NR V2X side link and LTE V2X side link. Also in the picture on the right hand side, we see that both the scenarios are covered where UE is connected to the network, which is inside the RAN coverage, or UE is out of coverage, where there is no network to support the resource allocation. Then from V2X, we move to the second pillar, which is Industrial IoT and URLLC enhancements for release 16. So release 15 was designed with basic URLLC features like low latency features like mini slot, multiple scheduling request, UE configured grant, UE processing capability. Also, it had high reliability with URLLC specific capabilities, and it was possible to multiplex Embp and URLC cases and prioritize URLC over Embp. But in case of release 16, there have been more features for even reducing the latency. For example, multiple HARC acts within a slot, compact DCI format for high reliability, increased PDCCH monitoring capability, mini slot based PUSCH repetition, enhanced PDCP duplication, multi TRP based PDSCH. This is all to increase the reliability of the link. Then improvements to intra UE Embp and URLLC multiplexing. So it's possible to have two HARC-ACK code books on and multiple active configured grants. Also, inside a UE, there is a prioritization of uplink data and uplink control. And also there have been some additional enhancements on uplink cancellation and uplink power control in the same area. Then a new area that has been introduced is about time-sensitive communications. So here there is more efficiency introduced where there is Ethernet header compression, downlink semi-persistent scheduling enhancement, and this includes shorter periodicity and multiple downlink semi-persistent scheduling. Looking at the physical layer enhancement for EURLLC, there have been enhancements in PUSCH where it's possible to configure grant, or it's possible to have a dynamic grant, and there is possibility of repetitions for PUSCH within a slot, and also it's possible to have 2 or more PUSCH repetition across slot boundary in consecutive slots, so adding more reliability. Also, out of order PUSCH scheduling is possible, out of order ARC-ACK is possible. TSN support for industrial IoT. So here, one key factor for integration between industry requirements and 3GPP 5G is time-sensitive networks, primarily in a manufacturing environment inside the industries. The time-sensitive networks are deployed for ultra reliability and low latency, and these protocols are defined based on IEEE 802.1. So to get a 5G wireless capability to replace the Ethernet based, the industrial Ethernet, which is based on TSN, needs the integration or support of TSN into 5G. So for that, enhancements have been done in physical layer to cover the URLLC cases. And in general, there are 3 main objectives to deliver industrial IoT. One is time-sensitive communication. Then at the higher layer, to increase the reliability by using PDCP duplication, and also addressing the intra-UE prioritization multiplexing. So this slide is not from 3GPP, but this is a good introduction on existing time-sensitive networking, which is used inside manufacturing industry, which is using the connectivity with industrial Ethernet. So for these components inside a factory, they are all connected by industrial Ethernet, and in industrial Ethernet, the core protocol for ultra reliability low latency is based on this 802.1 family of protocols for time sensitive networking. So if you look at the TSN components, they are synchronization, reliability, latency, resource management. In effect, the 5G does not replace the existing time-sensitive networking inside a factory. But what 5G does is that it adds capability so that the ultra reliability, low latency aspect of time-sensitive networking that was existing in a factory can be used over 5G. So 5G replaces in the industrial Ethernet, then it must have the capability for synchronization, reliability, low latency, so that it can effectively replace the wired industrial Ethernet with wireless 5G to make the Industry 4.0 a reality in terms of smart manufacturing and beyond that into multiple other domains. So the key idea was to explain here that this is a bit of a history from a vertical of industry, which is a factory, and 5G, when it's been designed, it has been inherently designed so that it can take these attributes, it can meet these attributes which are required by a factory. Moving on to the next slide. This slide explains the idea of time synchronization between a UE and a time sensitive network. So on the top here in the yellowish orangish color is the industrial network. The below in the bluish color is the grayish color is the 3GPP network. So both these networks have got two different clocks, and as you can see on the left hand side we have got the UE, which is no longer connected inside the industrial network by a cable. So the UE is connected to industrial network via 3GPP network, which means that we have to get 3GPP network and the industrial network purely synchronized for time sensitive networking. And this shows how the time synchronization is done. As you can see in the UPF, the synchronization is done between the grandmaster T1 and so this 3GPP network can be synchronized with the industrial network. And eventually the UE, the 3GPP network and the industrial network are all synchronized so that we can meet the ultra reliable and low latency use case. And whatever we are trying to achieve in a smart factory, we achieve that precisely and with accuracy, reliability in that action. Also, the below picture shows the solution for the synchronization between the UE and the UPF, where this is for the TSN time, and it shows how the PDU is time stamped. Each time it's flowing from one entity to the UE. For example, here the entity is UPF, from UPF to the UE, and then when it comes back, the synchronization time is calculated based on the offset in the local time. So it's a flow of messages with time stamping on these messages, and then eventually the synchronization is achieved by knowing the difference in time in receiving the message. Moving on to the next slide. This is a non-public network description here. So in NR, one key feature that has been introduced is a non-public network, which is very closely related to smart manufacturing or industrial IoT, because what this means is that there is all the features of the core network and all the features of the radio network can be used in isolation when we deploy a 5G based smart factory. So a factory with production could be used with 5G effectively when everything is contained inside that factory, including the core network, the radio. So this is a example of having a non-public network where it could be deployed in a variety of use cases. It could be that the operator provides some kind of services like part of the core where the radio access network can be connected to the core of an operator, or if a particular enterprise or a factory decides that they want to have everything managed by themselves, then they could deploy by themselves, manage the network on their own. And already in different parts of the world, there is a lot of initiative on this. There have been spectrums that have been allocated for non-public network, which is dedicated spectrum where nothing else happens. No operator runs its services, but it is primarily for non-public networks. In some countries or some parts of the world, it's also called as private 5G. And in some parts of the world, it's also called as local 5G. So there are two different models, as I explained. One is standalone non-public network, which is deployed by a NPN operator, which could be a owner of a enterprise or a factory. And then there is public integrated NPN, which is deployed with the help of PLMN, which is a public operator. Then mobile telecom operator. Then on the REN2 side, so there is information about both SNPN and PNP/NPN in SIB1, so that the device can understand what kind of network it is going to camp onto. And there is a limit in the number of NPNs that can be broadcasted. Moving on to the third pillar of 5G, it is based on NR unlicensed. So NR unlicensed is primarily focused in FR1 and Release 16, and the key reason for having NR unlicensed is to maximize the advantage of 5G by deploying it in maximum possible area of spectrum. And for this, there have been a lot of interoperability introduced. For example, carrier aggregation between NR and NR unlicensed, dual connectivity between LTE and NR unlicensed. Also, there is standalone NR unlicensed. And then we have got standalone NR cell-in licensed, where downlink is in unlicensed and uplink is in licensed. So different combinations. Also dual connectivity between licensed band NR and NR unlicensed. So variety of combinations to ease deployment. Some more details on NR unlicensed for Release 16. So there is improvement in the frame structure switching points, where it's possible to switch between downlink to uplink and uplink to downlink single or multiple times. Then this is the acronym. One acronym that has been used here is LBT requirements, which is listen before talk, and this is a key technology used in NR unlicensed. So also NR unlicensed can support a mode of operation where for a carrier all DL channel signals and all UL channel signals can be operated with same numerology. NR unlicensed has a discovery reference signal, which contains a combination of SSCVCH and CSIRS RMSI core set plus PDSCH OSI. SRS has been made more flexible in configuration. Then we talked about LBT. So there has been a new feature which is random access in two-step. So there have been enhancements to handle the two-step retch, and also it can move to four-step if there is a failure in LBT. So both can be supported, but it's just more to reduce the time to connect. Then there have been improvements in scheduling HARC, Rlm and Rram extensions, especially in the unlicensed spectrum. Also, inactive and idle mode procedures have been enhanced for NR unlicensed. Access priority has been introduced for control signaling. So if, for example, if there is a LTE along with NR unlicensed, then which is a higher priority, LTE signaling or NR unlicensed? So all these signaling radio bearer priorities have been introduced. Also support of mobility paging and enhanced system information acquisition in a NR unlicensed G node B has been introduced. The next slide is on general enhancements of 5G release 16. This is now moving on from the key pillars of enhancements to key improvements and key features that have been added as general. So if you look at here, if we compare MIMO between release 15 and release 16, so release 15 already had a lot of key features. Basically, it was based on high number of antenna elements. Type 2 codebook was introduced, which was useful for providing the better throughput in comparison to release 14 LTE. Also, flexible CSI acquisition reference design for scalability of future enhancements. And NR MIMO was designed to operate in high frequency bands via beam management. Although it was not optimized, so there have been improvements in release 16 to make the MIMO more effective. For CSI, the Type 2 codebook based CSI is extended for multi-user MIMO in case of release 16. This was not supported in release 15. Then the limitations with multiple TRP and PAN operations on release 15. So this was causing a lack of reliability. So there were features and enhancements done for improving the multiple TRP transmission reception point and multi-pane operations on release 15. So there was improvements in downlink control signal enhancements. Also, there have been enhancements in uplink control signal and reference signals, and addition of multi-TRP techniques for URLC requirements. In addition, there were enhancements for multi-beam operation, which is more focused on FR2. So enhancements on ULDL transmit beam selection, also UL transmit beam selection for multi-panel operation, which is a new feature. So multi-TRP we have seen that in release 15, but multi-panel is a new feature which helps the panel-specific beam selection. Also, beam failure recovery for SL with downlink and uplink as well as downlink only. Then there was more possibility to specify measurement and reporting. It could be based on either L1 RSRQ or L1 SINR. Another feature is about UE power saving in NR. So in case of release 15, there were some power saving schemes like BRX and BWP, bandwidth by part, which helps the UE power saving. But in case of release 16, PDCCH based UE power saving was introduced or has been introduced. So it's possible to send a wake up signal using PDCCH. And the monitoring occasions of the power saving signal is outside the active time is indicated to the UE by G node B with an offset before the DRX is on. Also, cross slot scheduling power saving techniques have been introduced. Also, there is a feature on power saving techniques of UE adaptation to maximum number of MIMO layers, where it's possible to define bandwidth part based on for MIMO configuration. Also, it's possible to indicate by the UE about its preference to tell the network what are the parameters that are used in RRC connected state, so that the network can make sure that if the parameters with which the UE is configured, if they are not optimized enough, then it can reconfigure the UE. Also, there has been relaxation on the RRM measurement, so that if the UE is not mobile or not moving, then the network is smart enough to configure the UE not to do those measurements, so that the power can be saved. This slide demonstrates the NR mobility enhancement. So the key focus here is to reduce the interruption time or the failure rate of handover. So the background is it's very easy to experience the signal degradation in high frequencies if the UE moves, and because there is communication based on line of sight and non-line of sight also. So there is different channel conditions. So in case of release 16, what has been done is that in ideal situation, it has been designed to achieve high handover performance with 0 millisecond interruption and with low latency and high reliability. What this means is that there is handover or secondary cell group change with simultaneous connectivity with source cell and target cell, so that there is no drop of the call. And another feature that has been considered is make before break using dual active protocol stack. And the third feature for reducing the interruption time is ratchless handover. So these three features are to reduce the interruption time. And then there are features introduced to improve the handover robustness, which is conditional handover and fast handover failure recovery. This slide shows the multi-rat and DC and CA enhancement for release 16. As a key summary, in case of existing release 15 DC and CA, it's deployed based on synchronous NR to NR dual connectivity, while the feature in release 16 focuses on more flexible deployment of NR dual connectivity by not worrying about the synchronization between the two G node Bs, and they can be asynchronous. Also, there are features for fast access to NR and increasing the robustness. So it's possible to have a early measurement reporting, and efficient and low latency serving cell configuration, activation, and setup, so that there is less signaling overhead. Fast MCG link recovery. This is applicable for both MRDC and NR to NRDC. So SCG link can recover very fast from MCG failure. This is done by utilizing the split SRBs during MCG failure. And then there is cross carrier scheduling introduced, but this is applicable for CA only. For DC, cross carrier scheduling does not work here. So it's possible to schedule PDSCH on the second carrier from the first carrier, even when there are multiple numerologies. Another feature of release 16 is integrated access and backhaul, where the access and backhaul are access anyways using the capabilities of multiple antennas, arrays, and communication via beams, but also it's possible to share the part of the radio or the antennas to communicate at backhaul, which can become more effective for deployment and network architecture for load balancing and flexibility of deployment. Another feature here is Srvcc, where there is handover from 5G system to 3G. This is to support the possibilities where there is no VoLTE supported by LTE network, or there is a direct upgrade from 3G network to 5G network where there is no LTE. So it's quite similar to the Srvcc from 4G to 3G. It's just from 5G system, which is from 5G core and 5G radio to 3G. Just the signaling is different, but the concept is exactly the same. Primarily to support the voice call. NR positioning. So in case of release 15, the positioning was primarily based on LTE based positioning, but in case of NR, the positioning capabilities was introduced inside the NR technology, where NR downlink and uplink reference signals were introduced for positioning. Also, UE measurements and G node B measurements based on the uplink downlink reference signals for positioning were introduced, and different functional interfaces in the network and signaling and procedures were introduced to help the UE to report NR RAT dependent positioning. Also, the extensions were done to LPP and NRPPA protocol for NR positioning. Moving on to 3GPP release 17 here. So in case of 3GPP release 17, sorry, there is a bit of a delay because I have to switch between the presentation and my browser because of the quality, but I think we will manage. We have got little short time also. So in case of release 17, in RAN 86 in December 2019, the RAN package for RAN 123 was approved, and the study items were defined and decided. So this is the stage 1, which is finished. Stage 2 work has just started, and this continues all the way in 2020, and then we get to RAN 1 freeze in early 2021, eventually finalizing the ASN1 for release 17 in Q3 2021. So it's around 15 months timeline from now till the point when the release 17 will be chosen and agreed in terms of all the specs. So in stage 2, the work has already started. In some areas the work will continue to start in coming quarters, and we will go through the next slide to see in more detail what are these areas. So this slide gives a summary of the release 17 study work items, where there are a number of items which have been introduced in release 17, but in reality none of them introduces any new technology. They are all about improving the release 16 and adding new use cases to support more applications of 5G. For example, there is low complexity NR devices, which is primarily focused on IoT, and which has got expansion of IoT into video surveillance, industrial wireless sensors, wearables. There are enhancements for small data, where it's possible to have more efficient small data and inactive data transmission for both uplink and downlink. NR side link has been improved for power saving, reliability, and reduced latency. Power saving because in case of release 16, NR side link was always on, but it has been made more efficient now in terms of power saving. Also, the number of use cases have been enhanced for V2x and into new areas like public safety and commercial use cases. NR side link also moves to FR2, which is more than 6 GHz and release 17. Extending the NR up to 71 GHz is another study item where it's being analyzed to reuse the existing waveform up to 71 GHz. This is also under study. So most of the items here that we see are either the study has been started or it will be started in next month. Then dynamic spectrum sharing enhancement. So PDCCH enhancements have been done for cross-carrier scheduling. Also, there have been URLLC enhancements for industrial IoT, where there is header compression aspects and there is extra slide on this. Then another interesting area that is being worked on in release 17 is NR and IoT over non-terrestrial networks, which is combining the non-terrestrial aspect using the NR, NT, and UE for LEO and GEO satellites, and also using the NTN for IoT, where it can be used for spaceborne and airborne vehicles. Then on NR coverage enhancement, so this is to increase the coverage of NR, because as we move from the use case of eMBB to massive IoT, the coverage becomes very important, because if you want to deploy in all things everywhere, then we need to increase the coverage here. Also, we need to deploy things in unreachable areas where indoor coverage penetration is also important. Then there are usual NB-IoT and eMTC enhancements, which are not related to 5G, but more about how to introduce the compatibility between the two. NR positioning enhancements, which are more adding more accuracy. Positioning in release 16 was up to tens of meters, while when we move to positioning in release 17, we are looking at sub-meter level, 0.3 meters or tens of centimeters. And then there are power saving enhancements on the network side and the phone side. So both have been quite important to make the network and the phone more efficient. Then multi-radio dual carrier and carrier aggregation enhancement. So this this feature is about efficient SCG and SLB activation mechanism. This is again about saving the network and UE power consumption. That's the primary driver. NR multicast has been introduced for V2x and public safety. Non-public networks have been enhanced. Then there are further enhancements on MIMO. So having more cases for mobility and better support for FDD. So MIMO is further improved. NR side link relay, this is more for improving the coverage when there is no network, using NR side link UE as a relay. So this is a quite key feature to improve the network coverage. Then there are improvements to support multi-SIM operation, integrated access and backhaul enhancements to make it more seamlessly integrated. And also on RAN slicing, where it's the whole network architecture has been improved to give the UE fast access to the cell that supports the slice that the UE needs to achieve the quality of service that it needs to use for its application. And also in case of there is a handover, then how to manage the service continuity if the target G node B does not support that slice. So all these advanced features have been worked upon in this release. So I will be very quick because I'm sorry that I have extended the time. NR Industrial IoT and URLLC enhancement. I think this is more to improve the UE feedback and CSI feedback enhancement, and also to have the capability of supporting the release 16 with unlicensed band. So expanding the use cases of industrial IoT into unlicensed. And also there is Intra UE multiplexing and prioritization of traffic. And there are improvements in case of time synchronization. So TSN, as we discussed before, there have been features that have been added for improving the time synchronization of the industrial network and the wireless 5G network. Also, there have been enhancements to MIMO, where we discussed enhancement on multi-beam operation, where there is target on FR2, but also applicable to FR1. Enhancement to support multi-TRP deployment, targeting both FR1 and FR2. Also enhancements on SRS, ESI. So this slide is about the low complexity NR devices, where there have been number of features introduced to achieve the NR Lite capability using release 17. So we can see there is focus on reduced number of UE, RX, TX antennas, UE bandwidth reduction. Release 15 SSB bandwidth should be reused and L1 changes minimized for UE bandwidth reduction. Half duplex FTD, also relaxed UE processing time and UE processing capability. Another aspect is about studying the UE power saving and battery life enhancement for reducing the capabilities wherever the cases are applicable, depending on the application of the device. Reducing the PDCCH monitoring, sending the DRX for RRC inactive and idle, and again reducing the Rlm reporting for stationary devices. Also, the key factors are that coexistence with release 15 and release 16 UE should be ensured, and the focus here for low complexity NR services is on standalone mode and single connectivity. And this is the last slide where we just demonstrate the Anritsu solutions for 5G. And just to be very quick, we have got different variety of solutions for 5G, but when we look at the relevance of the presentation today, we look at the 5G signaling tester, which is MT8000, which is used to test the different feature enhancements in RAN or core network. And this is used to test different aspects of the device, whether it's application or its advanced protocol R&D or its RF or any other advanced features. Currently, this platform MT8000 is supporting release 15 of 5G, but it is on track to support release 16 and in future release 17. And we are closely working with the standardization and our customers and partners to make sure that we continue to evolve as the 3GPP is evolving in terms of standardization. Thanks a lot for listening, and sorry about the delay, and there was a little bit of a mix-up with the technology also. I hope it was useful. Joe, if you are still there, over to you. Thanks.
Yes, thank you very much, Vikas, and thank you for everyone for listening in today. We do have a few questions to fire over to you, Vikas. Just conscious on timings, so perhaps we could quick fire through them. The first question is, what are the Release 16 enhancements for Industrial IoT?
So, Release 16 enhancement for Industrial IoT. I covered it in one of my slides. So this whole section is on Release 16 enhancements for Industrial IoT, where we are looking at physical layer enhancements, including the low latency for HARC ECNEC, higher reliability using compact DCI, increased PDCCH monitoring capability, mini slot based PUSCH, enhanced PDCP duplication, multiple TRP based PDSCH. Also, we are looking at enhanced Intra, UE, Embp, and URLC multiplexing. Also, we are having the enhanced support of time sensitive communications, Ethernet header compression, FPS enhancement, and also to have the details on a specific feature. There is PUSCH enhancement, which are about out of order PUSCH and out of order EC. And also there is time sensitive networking support for Industrial IoT, where the integration of the industrial network is done with the 5G technology, and we are replacing the industrial Ethernet with 5G Release 16.
Okay, thanks, Vikas. The next question is, in Massive MIMO, the UE is not mandated to support 2 simultaneous beams in Release 15. Typical UE implementation in Release 15 will have a single panel. Does this change for Release 16?
In terms of MIMO, Release 16 supports MIMO, 2x2 MIMO, if we look at the FR2. But when we talk about the multiple panels, multiple TRPs are supported in case of Release 16, but multiple panels have been introduced in case of Release 17. This is my understanding.
Okay. Next question is, what are the key verticals for applications of 5G in Release 16?
The key verticals are, as we discussed before, the key verticals are automotive and the Industry 4.0 driven vertical, which is primarily smart manufacturing, but it can also evolve into other verticals like smart agriculture, healthcare sector, but primarily the key verticals here are automotive and smart manufacturing, along with the usual Embp enhancements for broadband data.
Okay, and just a final one, it's more of a definition type question, this one, and that is, what does UPF stand for?
UPF stands for user plane function.
Okay, that's fantastic. That wraps up the Q&A session, and that will also conclude today's webinar. So thank you to all our attendees today, and particular thank you to Vikas for a very interesting presentation. If anyone does have any follow-up questions, then please feel free to send them over to info@electronicspecifier.com, and we will share them with Vikas and Anritsu and endeavour to get them answered for you. But I'd just like to say thank you again for your attending, and that now concludes today's webinar. Thank you.